Hi, I'm Shyamala, working as Assistant Professor of Mathematics in Humanities and Sciences Department in Nalla Narasimha Reddy Institute of Technology. I teach Mathematics 1. Mathematics 1 is for first BTech students. In this Mathematics 1, Unit 2 is Eigenvalues and Eigenvectors. In this video, I'm going to discuss about the eigenvalues and eigenvectors definitions and its applications. First, I define eigenvalues and eigenvectors of a matrix. Eigenvalues and eigenvectors are defined on a square matrix. So, first we take the generalized n by n matrix A. A equal to Aijb and n by n matrix. A non-zero vector x is said to be characteristic vector of A if there exists a scalar lambda such that Ax equal to lambda x. So here we should remember that a characteristic vector is a non-zero vector x and lambda is the eigenvalue or characteristic value. So therefore, if Ax equal to lambda x, x not equal to 0, we say that x is an eigenvector or characteristic vector of A corresponding to the eigenvalue or characteristic value lambda of A. So for each characteristic value, there exists a characteristic vector. So now we will see how to find the eigenvalues and eigenvectors of a matrix. So again we take the definition. By definition we have, if we have a matrix A, then x be an eigenvector of A corresponding to the eigenvalue, then by definition Ax equal to lambda x. Ax equal to lambda x can also be written as Ax equal to lambda I into x. I is the identity matrix. The order of the identity matrix is equal to the order of the matrix A, and that can be written as A minus lambda I into x equal to 0. This A minus lambda I into x equal to 0 is a homogeneous system of n equations in n unknowns. Why in n equations and n unknowns means because A is the n by n matrix, this will also be a system of equations and in n equations and n unknowns. And we have seen in the definition that x is a non-zero vector. So for a homogeneous system of equations to have a non-zero solution, we must have always determinant of a minus lambda I into x equal to 0. That is what we have written here. This will have a non-zero solution x if and only if determinant of a minus lambda I equal to 0. So now, this determinant of A minus lambda I is called characteristic polynomial in lambda of degree n. Only A minus lambda I is called characteristic matrix of A. Determinant of A minus lambda I equal to 0 is called characteristic equation in lambda of degree n. Solving this equation, because this equation is of degree n, solving this equation we get n roots. Those n roots, let us suppose them as lambda 1, lambda 2, lambda n of the characteristic equation. These are the characteristic roots or eigenvalues of the matrix. Also, these are called as latent roots. Corresponding to each of these eigenvalues, we can find the characteristic vectors x. So, if we are taking lambda 1 as eigenvalue, its corresponding eigenvector we can take as x1. But how we find eigenvector corresponding to an eigenvalue is, again by taking the definition A minus lambda I into x equal to 0. If we are finding eigenvector for lambda 1, then we will write it as A minus lambda 1 I into x1 equal to 0. And in general, we will say that for an eigenvalue lambda I, A minus lambda I into xi equal to 0, xi is called the eigenvector corresponding to the eigenvalue lambda I and I equal to 1, 2 up to n. So this is a way of finding the eigenvector corresponding to eigenvalue. And how do we find eigenvalue is by taking determinant of a minus lambda equal to 0. Solving it, we will get all the eigenvalues, and for each and every eigenvalue, we can find the eigenvector by taking a minus lambda into x equal to 0. So this is a definition and finding the eigenvalue and eigenvector. Now, applications of eigenvalue and eigenvector. Applications of eigenvalue and eigenvector. So here we have wide usage of eigenvalues and eigenvectors in our daily life. First, we always search for any word or for anything. We always choose Google every day. So in Google, what happens is whenever we type a word, that Google, what it does is it takes the word and it searches the background. What happens is that search engine takes that word and searches all its millions of web pages which are available, and in which web pages this word is matching, all the web pages will be displayed on our screen. So this background work is depending upon eigenvalue and eigenvector, and this algorithm is called as page rank algorithm. And every day we are nowadays we are using smartphones. To unlock a phone, we use face recognition um, concept, and face recognition concept is also using the eigenvalue and eigenvector only. And in machine learning, in big data, if we have big junk data, and from the junk data if we want to extract important information only, then they will use eigenvalue and eigenvector concept. And another usage is principal value decomposition. Like this, we have so many applications in our daily life, not only in computer science. um, in civil engineering also we have many applications, in mechanical engineering. So there are many usages of eigenvalues and eigenvector in our daily life. So in this video we have learnt about definition of eigenvalue and eigenvector, and how to find the eigenvalue and eigenvector for a given matrix A, and also the applications of eigenvalues and eigenvectors. Thank you.